So we're going to take a look at section 2.3, which is on solving linear and quadratic equations. So most likely things you've done before, but when we get to quadratics, there's different ways we can solve them. And if we're going to use a certain method, like quadratic formula, I want to know, why does that method work? Right? That's kind of what's more important in this class. I mean, plugging in the A, B, and C and getting an answer, okay, that's good. But the question is, why does that formula work? Where does negative b plus or minus the square root and all that stuff come from? That's a much more important question. So we'll take a look at that. So remember, we talked about an equation, I think maybe the first lesson we had. So an equation is when you have two expressions. They can be numeric or algebraic expressions, and an equal sign between them. If we have a variable in the equation, like when we do y equals mx plus b, the independent variable is x, we could say that we have an equation in x. In x just means that's the independent variable. We don't always have to use x. It's the most common one, especially when you're graphing. But sometimes if you're doing a word problem and it has something to do with like number of hours worked at a job, you might do h for hours. Okay. So you can use different letters. Solving an equation means to find the value of x that makes it true. Generally, for linear equations, if they're not a special case, how many solutions do linear equations have? Yeah, just one. Are there special cases? Yes. You can get no solution. You can get infinite number of solutions. But if it's not a special case, linear has one. So I mentioned that there are special cases. One of the special cases is when you have all real numbers as a solution. And the way that could come up would be in an equation like this. If I gave that in Algebra 1 and asked my students to solve it, right away you might not know that it's an identity, but it is, because when you start to distribute, you get 3x plus 3 minus 1. And when you combine like terms, you get 3x plus 2 equals 3x plus 2. So you have the same thing on both sides. Whenever that happens, that means you have an identity. No matter what number you plug in for x, it will always work. Okay, so that's more of a special case. The case that we have more often is a conditional equation. Okay, that's an equation that it's not always true, like an identity, but it could be true if you pick the right value for x. So in this case, what would be the condition that would make it true? If what? Technically.
I'm sorry, that's the question again.
So what would be the condition that makes that true?
If x equals 5.
Yeah, if x equals 5. Perfect. Yep. Okay, so that's a conditional equation. And I don't think I did an example of the third case, but the third case would be a contradiction. That's where when you try to solve the equation, you end up with something. Let's say you got to this step. And after you distributed and combined like terms, you ended up with something like that. Well, when you subtract 3x from both sides, you've got 2 equals 4. That's not true. So what would happen in that case is there are no values that would ever make the equation true, and there's no solution. If you're trying to verify that a number is a solution, what you would want to do is take that number, plug it back in, and see if you get a true statement. If you plug it back in and you get a true statement, then that means it worked. Okay. If you take your number plug it back in and you don't get a true statement, then it's not the correct answer. Or you made a mistake checking. So let's look at this one. First, looking at that equation, what would make that a little bit harder to solve, maybe, where you wouldn't necessarily see that in Algebra 1? What makes that equation a little bit harder to solve? Yeah. Yeah, it's cubed. It's a cubic. I'm not saying you can't solve cubics. Some of them you can solve very easily if certain things happen. But in general, unless something special happens, a cubic could be a harder equation to solve algebraically. There is a formula to do cubics, like the quadratic formula, but it's generally not a formula we use. It's a little bit lengthy, but there is one you can use. The goal in this one isn't to solve it. It's just to verify that -2 is a solution. Now, if -2 is a solution, -2 is an integer. If a cubic equation has an integer solution, then we can deal with that no problem. Okay? Very, very easy to solve a cubic if there is an answer that is an integer. Even if there's an answer that is rational, okay? A little more complicated than integer, but still a fraction. If there's an answer to this problem that I can write as a fraction, then I can solve any cubic you want me to solve. If there are no answers that are rational, then you're a little bit stuck. Okay? That's going to be a little bit harder to solve. All right, so how do I verify that -2 is a solution? Yeah.
Replace x with -2.
Right, replace x with -2. And when we replace x with -2, the goal, in this case, is to see if the left side comes out to 0. Jaden, what's -2 cubed?
8.
-8. Okay, and then Annalise, what's -2?
4.
Minus. So minus a -2.
Oh, 0.
No, not 0. What happens when you subtract -2? It turns into something. It just turns into +2. Yeah. So we have -2 cubed. We did that. Minus -2 is +2, +6. -8 plus 2. Nick, what's that going to give me? -8 plus 2. -6. And if I combine those together, Travis, -6 plus 6? 0. So what does that mean about -2? It means it's a solution. Okay. And since it is a solution, I could find the other two solutions very easily. This -2 would allow me to turn this cubic into a quadratic, which I could then solve from there. Right? We're going to learn how to do that later on. Not today. Right. Any questions on verifying that that was a solution? Okay. So that is the general form of a linear equation. Can someone tell me, what is this saying? I'll make sure we understand math language. Yep.
Does it mean A and B are real numbers, but it's not equal to 0?
Exactly. It means A and B are real numbers, but there's one number A cannot be, and that is 0. Yep. So anything that can be written in that format is a linear equation. And I say anything that can be manipulated to be in that format. So if you had something like 3x plus 4x equals 6, Well, no, that's not in the format ax plus b equals 0. But if I bring everything to the left side, I have negative x minus 6 equals 0. And now it's in the format ax plus b equals 0. It could be a plus b, or technically it could be a minus b, and that's fine. So in this case, a is like negative 1. Yeah.
What does that E mean? What is it? That
E means it's an element of. Yeah, and that's why it is curved like that on purpose. Yeah. So A and B are elements of the real number system, and there is one value A cannot be, which is 0. If A is 0, then what happens is you wipe that term out, and you end up with what's called a constant equation. That's like a horizontal line, y equals 2. So to have it be linear, there has to be an x variable in the equation. All right, so let's see if we can solve this one. All right. What would my first step be to start to solve this? What do you think?
Like distribute the 2.
Yep, distribute the 2. And if you do that, what do you get?
4x minus 6.
4x minus 6, very good. Len's my next step.
Now you can distribute the 3.
Yep.
Parentheses.
And what do you get if you do that?
You will get 3x plus
3x plus 3. Okay, Layla, how about my next step? Yeah, and where do you see some like terms? Yep. So if you combine all that together, well, whatever you can, what would you get on the left side?
7x.
So we got 7x, and then negative 6 plus 3 gives me minus 3. Good. Okay, my next step, Marin, what would I do from here? Subtract what? Subtract 2. Okay, so I'll do the minus 2. And what else can I do at the same time?
Subtract 5x or 7x.
Which one do you want to do? Okay, so we're going to subtract the 5x from both sides.
Or no, 7x.
You want to do the 7x?
Yeah.
Okay. I think it's a better choice. The choice isn't wrong, it's just going to lead to an extra step. So 7x gone, 2's are gone. Negative 3 minus 2 will give us negative 5. And 5x minus 7x gives you negative 2x. Right, now we're down to a one-step equation. And Emma, what would be my last step?
Divide both sides by 2.
By what?
2.
Okay.
Negative 2.
Okay, yep, negative 2. So that cancels out your negative 2, and we get x equals 5/2, so we're at 2.5. All right. So hopefully nothing new there. It's just solving a linear equation. Any questions on that? Okay. Before we get into quadratics, we're going to look at a couple applications of linear equations. And one of them is solving an absolute value problem. Okay, when we are solving an absolute value equation, it ends up turning into 2 linear equations that we solve together. Okay, so to solve an absolute value equation, we're going to split it into 2 equations. The first equation that we split it into is going to be the same as the problem we're given. We're just going to remove the absolute value bars. Okay, so you're going to have something like this. Something like that. So the first equation that we do is the same as the original without the absolute value bars. Now, one thing I should mention. The absolute value needs to be isolated on one side. That's isolated. The absolute value's on the left, and there's nothing else outside it. This is not isolated. Let's take the same problem, and let me do, let's do something like this. That bottom one has a +7 on the outside of the bars. How would you move that +7 to the right side to isolate the absolute value? Yeah.
Subtract 7 from both sides.
Yeah, you'd subtract 7 from both sides. And then this problem is identical to the one that's above it. When you subtract 7 from both sides, it turns into absolute value of 3x plus 4 equals 5. Okay. So that would be your first step if you have to do this step. You may or may not. Okay. Now, looking at that top one again, absolute value of 3x plus 4 equals 5. What is inside here can come out to two different numbers, and they will both work. What are the two numbers that 3x plus 4 could come out to? And both of those numbers, when we take the absolute value, give us 5. Yeah?
Positive and negative.
What is it?
Positive and negative.
Positive and negative. Making sure I heard you right.
3x.
You said 4, right?
Yeah, I said
No, if what's inside this green circle comes out to 4, and then you take the absolute value of that, you're going to get 4. 4 will not equal 5. What does what's inside that green circle have to come out to? There's two values it could come out to. I'm not asking what x has to come out to. I'm just asking what's the whole green circle. Yep.
5 or -5.
5 or -5, exactly. So if what's inside here comes out to a 5, and you take the absolute value of it, you'll get 5. If what's inside here comes out to -5, and you take the absolute value of it, you will also get 5. So that's why we're splitting it into two equations. This one is basically setting what's inside that green circle right here equal to 5, and then solving it. The bottom one is setting what's inside that green circle to -5, and then solving it. So that second one, we're going to take out the absolute value bars just like we did before, but we're going to set it equal to the opposite of the number that's on the other side. So it could come out to 5, or it could come out to -5, and both of those would work. Once we set those up, then we actually have to solve for x. So what would make this green circle come out to 5? What would you fill in for x? What would make the green circle come out to -5? What do you fill in for x? Okay, so let's try this. Okay, first question, is the absolute value isolated on one side? Raj, what do you think? What is it? Yeah, it's already isolated, and we are ready to split it into two problems. What would be my first equation that I could split that into to solve for x? Oh, Marcel?
2x plus 3 equals 5.
Yeah, either 2x plus 3, either this has to come out to 5, or what's the other equation I would set up to solve that? Yep.
2x plus 3 equals -5.
Or this has to come out to -5. Those are the only two things that it could come out to. And now we solve each linear equation separately. So we get x equals 1. Okay. When we minus 3 there, we get 2x equals -8. which means x is negative 4. Any questions on how we solve that absolute value? Okay. What if I had something, I'm not going to go through all the steps, but what if we had something like this? What would be your first step there? Yeah?
You have to divide by 4 to isolate the absolute value.
Yep. So here, your first step would be to rewrite the equation. 12 divided by 4 gives me 3. Now I'm ready to split it. How about if I had something like this? What would be my first step there? Yeah?
Would you just separate them into two equations?
I wouldn't bother with that.
Distance can't be negative, can it?
You can't have an absolute value ever come out to a negative number. So you can split that into two problems and try to solve it. But if you take the absolute value of what's inside there, it'll never be negative 4. So in that case, that's a no solution. So when you look at an absolute value problem, if it's equal to a negative, I wouldn't even bother solving it. I would just say no solution. So applying that reasoning here, what if I had, let's say, that one. What would you say for that one? Yeah?
You have to add 10 to both sides.
But it's equal to a negative, so I thought it was no solution.
No, because there's 10 outside of the absolute value.
Right.
You have to get rid of that.
Right. It is equal to a negative, but it won't be when you isolate the absolute value and add 10 to both sides. Okay, so you gotta be careful. So that one is perfectly doable. All right. Any questions on that? Okay. So the application I want to look at for solving linear equations is a mixture problem. In a mixture problem, they're generally going to tell you you have two different solutions to mix together, and they're going to have two conditions. When you're done mixing them, they want you to have a certain volume of liquid. And the other condition is they want you to have a certain concentration of the liquid. So you might have, say, a 10% solution of like hydrochloric acid and a 30% solution. So you got 10% and 30%. I want to mix them together. So when I'm done, I get 14% solution. And I want 100 gallons of it. So I need to know how much of each one do I mix to get exactly that strength acid and 100 gallons of it. That's the idea. So this requires setting up two equations. One equation for the amount of liquid you're going to have, and then another equation that takes into account the concentration. Well, the amount of liquid one, that one's pretty easy. I said to you I wanted 100 gallons of liquid when I'm done. You're going to need two variables. And you could just say use X gallons of the first solution and Y gallons of the second solution. And when you mix the two together, you end up with 100, or whatever amount they tell you. That doesn't take into account anything with the concentration of the solution, which is usually a percentage. Like a 10% solution, 50% solution, things like that. To take into account the concentration, we need the next formula. So if I had, let's say that I had a 50% solution of some chemical. Okay, let's just say 50% solution of an acid. And let's say that right now I have 30 gallons. Out of the 30 gallons, how much of my solution is acid? How many gallons? I've got 30 gallons in front of me, and the strength of the solution is a 50% strength. Not all acid. If it was all acid in front of me, it would be 100% strength. But it's only 50%. Yeah?
15 gallons?
Right. In this case, I would have 15 gallons. Right? What if I had a 20% solution? Okay, same volume. I've got 30 gallons in front of me, and I have a 20% solution. That's the strength. How many gallons out of the 30 are actually acid?
Oh, 6 gallons.
6. Yeah, 6 gallons. That's 20% of 30. So the second equation is basically a concentration, in this case 20%, times an amount. So it's the amount of acid in the solution. That's what the second equation is. And you calculate that by doing the concentration times the amount. Now, you have to do the concentration times the amount for the first solution. Then you have to do the concentration times the amount for the second solution. And this gives you, technically, the amount of acid in solution number 1. This gives you the amount of acid in solution number 2. Then when you mix them together, you're getting a total. And that's what the last one gives you. If you take the final concentration that they give you in the problem and multiply that by the total, this is the amount of, I'm using the word acid, but it could be any chemical. It's the amount of acid in the total. Okay, so the first equation is purely just an equation for the amounts. The second equation, technically the second equation is still an equation for amounts, but it's just focusing on the amount of the acid in the solution, nothing else. Okay. So those are the two equations we have to set up. We're going to end up with two variables, and then we're going to have a system. So remember, systems can be solved with, what's one method you can use to solve a system? Yep.
Substitution.
Substitution, another method. Yep.
Elimination.
Elimination. Yep, perfect. You can try to do the substitution in your head. That can be a little confusing. So if you can do it later on, that's fine, but I'm not going to do anything like that in my head for this. Okay, so let's look at our problem. Okay, we have two solutions. We have a 10% and a 25%. We want to mix them together to get 15 liters of solution. And we want the strength of it to be 12%. So how much of each do I mix together? First thing we need to do is pick some variables. Okay. What letter could I use to represent, or what do you think would be a good letter to use to represent the amount of liters that we're going to use for the 10% solution? Good variable, Marcelo, what would be a good variable for that?
L
L? How come?
for liters.
Liters? Well, we've got two solutions. So we're going to have a certain amount of liters in one and a certain amount of liters in the other. So we probably want to use something that will clearly identify which solution is which. So So we don't look back and be like, wait, was L 10% or was L 25%? What do you think we would use for the 10% solution? Yeah?
Do something on B1 and B2 for like volume 1 and volume
Okay, yeah, you could use volume 1 and volume 2. That would differentiate it. Have they already differentiated it for me? What letter did they use for the 10% solution? Yeah. Hey, so just the way they wrote the problem, why don't we let A be the amount of the solution. Hey, that's pretty simple. Let A be the amount of solution A, and then let B be the amount of solution B. Okay. So what do we know about the total amount of liquid we want to have when we're done? Vanessa. We want to have 15 liters. So could you write an equation that takes into account mixing these two solutions together and getting a total of 15 liters? A plus B. And we got to make that into an equation. Perfect, equals 15. If that's all you knew, well, then you could say maybe it's 1 liter of A and 14 of B, or 2 liters of A and 13 of B. There's an infinite amount of answers. But we not only want to have 15 liters, we want to have 12%. So now we need to set up an equation that takes into account the percentages. And that's always going to look something like this. That's the same format that I just wrote right up there. So now, let's do that. Okay, so this is going to be solution A, solution B, and the total. Now remember, whenever you use a percentage, and this is pretty much always true for the equations that we've been working with, you have to change percentages to decimals. What's the concentration of solution A? As we're going to fill it in right in the first parenthesis.
Would it be
0.1. And what's the amount of solution A? Liv? A. Yeah. A is the amount of solution A. What's going to go in my second set of parentheses? Yeah.
0.25.
0.25. And the second one right here?
B.
B. So that calculates the amount of acid in solution A. That's the amount of acid in solution B. Now, we've got to get at the total. What's the final concentration that they want you to end up with? Oh, Gregor?
15?
Was it 15%? And how would you write 50? Was it 15? I don't remember.
It was 12.
It was 12, okay. What was, how do we write 12 as a decimal?
0.12.
And what was the total amount of liquid?
15.
That was the 15. So that side is generally a number. Right? On that second formula, we can multiply that out and just get a number. So let's do that. 0.12 times 15. 2 times. That's going to give us 1.8. I'm just going to put it above it for now, and I'll rewrite it all in a second. Okay, so equation 1, A plus B equals 15. Equation 2, if I clean that up a little bit. There we go. That one, and that one. What method do you think would work pretty well here? Substitution or elimination? Oh, Ethan?
Substitution.
Okay, which equation would you work with to do substitution to isolate a variable? The top one or the bottom one?
Bottom.
A lot of decimals in that bottom one.
Top.
Yeah, I'd work with the top one. Could you isolate a variable for me in the top one?
A equals 15 minus B.
A equals 15 minus B. Perfect. Okay, so now we've isolated a variable. What am I going to do with that 15 minus B now?
Substitute it for A.
Right here?
Yeah, the bottom.
In the bottom one, yeah. So we're going to take that, and we're going to fill it in right there, and then we're going to solve. Okay, so 0.1 times 15 minus b equals 1.8. Okay, distribute that out. 0.1 times 15 is 1.5. Minus 0.1b plus, I'm sorry, I put an extra 0. I didn't mean to do that. 0.25b, just copy it down from up above, equals 1.8. Okay, combine like terms. What's 0.25b? Take away 0.1b. How much? That's if you took away 0.01. We're taking away 0.1. 0.15. Yep. So combine your b's together. Bring the 1.5 to the other side. That's going to give you 0.3. And what's my last step?
Divide both sides by 0.15.
Divide by 0.15. That's gone. And what's 0.3 divided by 0.15? Yep. 2. Yep. So we need 2 liters of solution B. Don't forget about solution A. How many liters of solution A do we need? Yep.
We need 13.
13, because we needed a total of 15. Okay. And that's a pretty typical concentration problem and how it usually works. Okay. Any questions on setting up those equations and then solving? Again, you might not have done it in a while, but you should be pretty comfortable with substitution and elimination as methods for solving a system. All right, so the last thing we're going to look at is quadratics. So quadratics are in the form ax squared plus bx plus c. So it's like a linear, but you've got that squared term in front. In order to be a quadratic, the a, b, and c have to be real numbers, but a can't be 0, because if a was 0, what kind of equation would that be? Assuming b wasn't also 0. Yeah? It would be linear. Okay, if a is 0, it makes it linear. So we don't want a to be 0. Okay, so one way to solve a quadratic equation is to factor. So this is not an entire lesson on factoring. Factoring in Algebra 1, you spend probably 3-4 days on. Right? We're just going to try to jump in and see if we can factor the problem. Factoring is something that's important, especially when we get into solving polynomials that are higher than quadratics. We're going to need to know how to factor pretty quickly. All right. So 2x squared plus 5x minus 3 equals 0. what's going to be in the first term in each set of parentheses? Yeah.
X.
X and what else?
I don't know.
Vince?
Maybe 2x.
It has to be a 2x. Yep. 2 is a prime number, so the only way you can multiply two numbers to get 2 is 1 and 2. So you need a 1x and a 2x. Now, looking at your signs here gives you a hint at what your signs are going to be down here. What do your signs have to be when the middle is positive and the end, the constant, is negative? Josh?
First one would be addition, the second one subtraction.
Okay, we do need an addition and a subtraction, so we need one of each, and it does matter which one goes where, because they are not, 2x and x are not the same. If they were x and x, then it wouldn't matter. So let's try it the way you said it, which was, which one first?
Addition.
Addition first, subtraction second, okay. And now, we're looking at the 3. 3 is a prime number. Only way you can get 3 is if you multiply a 1 and a 3. And it makes a difference which one you put where. Where do we want to put the 1? Dari? First or second?
Second.
Second, okay. Let's check it and see what happens. So we get 2x squared. 2x times negative 1 is negative 2x. 3x, and when you combine negative 2x and 3x, you get 1x. But we have a 5x in the middle. Okay, so we got to fix that. All right, so what do I have to adjust? Yeah.
Swap the 3 and the 1.
Okay, let's try swapping the 3 and the 1. So let's do 3, 1. Now we get 2x times negative 3 is negative 6x. 1 times x is x. Add them up. Negative 6x and 1x gives me negative 5x. Better. Still not quite there. So what do we need to do now? Yeah?
Flip the signs.
Flip the signs. Plus, minus. Now when you do it, you get 6x minus 1x, which is 5x. Perfect. Okay, so now we factored it. And what do we do with each factor in that quadratic? Yeah?
Don't we make them into two equations that both equal 0?
Yes, you set them both equal to 0, setting up two equations. Perfect. 2x minus 1 equals 0. X plus 3 equals 0. And now you have two linear equations to solve. So you're going to get x equals 1/2. X equals negative 3. Any question on that? Well, that's great if factoring works, but factoring, if you just randomly make up a problem, is probably not going to work. So what else can you do if you can't factor a quadratic? Yeah?
Quadratic formula.
Quadratic formula. Now, the goal of this lesson is not to show you how to use quadratic formula. Okay, hopefully you already know how to do that. The goal is to look at why. Why is it negative b plus or minus and all that other stuff? Where does that formula come from? And that's what we're going to look at. Now, besides factoring in quadratic formula, what is one other way you can solve a quadratic? Not graphic, not a visual. This is an algebraic method. We've talked about this method. Today. Before I started the video. Completing the square. So another way to solve a quadratic is to complete the square. So what we're going to do is complete the square. But we're not going to do it with numbers. We're going to complete the square with a generic quadratic, and that is going to give us a formula. Any idea what formula it's going to give us when we do that? There's a name for this. Yeah,
Is it the quadratic formula?
it's the quadratic formula. So we're going to complete the square and watch what happens. Okay. So we have ax squared plus bx plus c. The a, the b, and the c would be any real numbers, except a can't be 0. And you'll see why a can't be 0 in a little bit as well, because that would be another problem, which we don't want to have. Okay, first step, set it equal to 0. What's our second step when we're completing the square? Yep.
Move the constant.
Okay, let's move the constant to the other side. All right, so now we've got that. What do we do after we move the constant to the other side? Yeah.
Divide b by 2 and then square it.
No, something we got to do before that. We are going to divide it. We're going to divide something by 2 and square it, but we got to make sure of something first. Yeah.
I'll factor out a.
Right. We have to factor out a because the number in front of x squared has to be a 1. So Marcelo, if I factor out a, what does that leave me with on the left?
X squared. B divided by a.
Yeah. B divided by a x. Because if you distribute the a back out, you get ax squared plus bx. Goes right back to what you started with. Now we need to complete the square. So that's where we add. Let's see. Do we want to? Yeah. So now let's complete the square. Okay. In order to complete the square, we need to do 2 things. First, does anybody remember what we're going to use to complete the square? Like in this case. What are we focusing on? Well, 2. What do we focus on to complete the square? Help them out, Lens? What is it? Well, I don't really have a b there anymore. I have an a, I have an x squared, I have a b over a, and I have a negative c. We don't have a b by itself anymore.
So then what do we do? B over A?
Yeah, it's the b over a. That's exactly what we're going to focus on. Okay? So what do I do to the b over a to complete the square? Okay. That's the second step. What's the first step?
You divide it by 2.
Divided by 2. What's b over a? I'm just going to do it off to the side. What's b over a divided by 2? Yeah?
Would it be B over 2A?
Yep. It would be b over 2a. And then we have to square that. Okay? If we square that out, we get b squared over 4a squared. So that's what we need to put in the parentheses. So, you know what? Before I actually write anything here, to make this a little bit simpler, so we don't have this a, how could I put this a on the other side? Just so it's not, I just don't really want it hanging out in front here. Yeah?
Divide both sides by A.
Yeah, let's just put that over here. It's going to make it less annoying than having it there. So now we have x squared plus b over ax, and then what we added on both sides, b squared over 4a squared. And if you add b squared over 4a squared on the left, you also have to add it on the right. Okay. Any questions on that? Okay, now we need to factor this left side. It's going to factor into x plus, and when you factor it, it's always half of that middle term. It's like the first step when you were completing the square. That's what would go right there. Because if you FOILed that out, you'd get x squared, and then you'd get one copy of x times b over 2a, another copy of x times b over 2a, and when you combine those together, it would be b over ax. So you can FOIL that out and check it, but when you FOIL that, you get that. And then b over 2a times b over 2a is b squared over 4a squared. That is how it factors. Now, that right side, let's just switch the order, okay? Because it's going to look a little nicer if we write it this way. B squared over 4a squared minus c over a. Right? There's a minus c in the quadratic formula, so we're starting to maybe see. We got a b squared, get some things going on here. Now, if I want to combine these two fractions together, what do I need to have on the right to do that? Travis, what do we need to combine these two fractions together? How do you combine? When you want to do subtraction with fractions, there's a rule. You've got to make sure you have what? Have what?
Them equal.
No, they don't have to be the same. Like you can subtract two fractions that are different as long as they have same denominator. What would be your common denominator between these two?
4a squared.
Yep, 4a squared, exactly. So we're going to try to get a common denominator of 4a squared. That means I need to multiply the bottom by what? Yep.
By 4a.
I need to multiply that by 4a, and that means I need to multiply the top by 4a, minus 4ac. Okay, so let's keep going. Now we've got b squared minus 4ac all over 4a squared. Okay. Now we're trying to get this x by itself. That's the goal. I can't do anything to what's inside these parentheses until I get rid of that exponent of 2. How do I get rid of that exponent of 2? Yeah.
Square root both sides.
Square root both sides. Okay, so now watch what's going to happen here. We have x plus b over 2a equals, and remember when you take a square root, there are two answers. So we have a plus or minus. In the top, there's not really a lot we can do with that. It's b squared minus 4ac over, what's the square root of 4a squared? Yeah, 2a. Now, the only thing that's left is to subtract this b to the other side, and the b will become a negative. So we end up with x equals, move the b to the other side, and the nice part is I already have common denominators, so when I move it, I can put it all in one big fraction. So negative b plus or minus square root of b squared minus 4ac, and all of that is over the denominator you had. There you go. So by completing the square with a generic quadratic, you get the quadratic formula. Any question on that? Okay, it's all letters, so it's a little bit harder with letters, but it's the same exact thing we've done with numbers. Okay. So just a reminder, in the quadratic formula, that part under the root is called the discriminant. Okay, that's a name for that part under the root. Remember, to use the quadratic formula, you need to write your equation like this. If your equation is like this, you're not ready to use quadratic formula. You might think b is 4 when b is really negative 4, because you got to move it to the other side. That one's ready to use quadratic formula. Okay, so always make sure it's in standard form. Is that one ready for quadratic formula? No, you gotta minus the 1 to the other side first. And that was another rectangle problem, but we can take a look at. Okay, so you've already done page 88. That's done. Okay, so the homework is on page 96. And it's all solving linear and quadratic equations. So we'll take a look at homework tomorrow. We'll finish our material for the week, 2.4. There'll be a review video. There'll be a review topic list at the end of tomorrow's video. And if anybody comes for extra help, there might be an extra help video that we'll use the whole week.